Hi. Yeah, thank you for being here after lunch. I'm going to talk about Ambassador, Native API Gateway. My name is Florian Weiner. I'm active on Twitter at Weiner. Certainly more animal pictures than technical contact recently. Maybe that changes again. I work for Tarrant Solutions. We have a few offices, one in Bonn, one in Cologne, one in Berlin. And I'm going to quickly define what I mean when I speak about an API. I'm going to use Christian Poster's definition here. And an API is an explicitly and purposefully defined interface designed to be invoked over a network that enables software developers to get programmatic access to data and functionality within an organization in a controlled and comfortable way. So when I speak about an API here, I mean the entry point into an organizational entity to get to their functionality or data. That means not just because we can communicate with something over the network, with a piece of software over the network, does not mean that this is an API by that definition. What is an API gateway? There's another definition that I think is very, by Chris Richardson on the Microservices.io website, or in the Microservices book, pattern book, chapter 8. An API gateway is a single entry point for all clients. The API gateway handles requests in one or two ways. Some requests are simply proxied, routed to the appropriate service that handles other requests by fanning out to multiple services. API gateways are commonly used to terminate TLS, authenticate authorized requests, or proxy requests to upstream systems. Of course they are. Or rate limit requests. This is all something that you do with API gateways, and they can do protocol translation, for instance, HTTP to gRPC is something that you commonly do on an API gateway, or do something more complex with fanning out and collecting data. Again, for instance, embed the haters links and then hand it out JSON document that is sent to clients that can't traverse links or something. API gateways can get arbitrarily complex, but are roughly categorized in a few different categories. So they're not strict categories. There's some overlap, but there's basically a handful of categories that you can use to speak about API gateways. There are the classical reverse proxies, like for instance HA proxy, which has been around for quite a while and does come from a different field of problems to solve, came to solve a different set of problems. What can we use in API gateway? There's the Nginx, which is edging closer to something that would be cloud native now, but it's still can still be used as a classical reverse proxy. Or if you really wanted to, you can realize an API gateway with a general Apache HTTP server. Then on top of that, they often sit a bunch of API management applications. For instance, Kong is commonly used for that, which allows you to authenticate, authorize requests, rate limit them. Or MuleSoft, which comes from the ESB world. Or 3Scale, which is a product by Red Hat. However, and there's the way to build your own API gateways, of course, which is if you want to, and then Vertex is something that can be used as is Node.js or Spring Cloud Gateway or its predecessor on the Spring world, Zool would also be known. Then there's this new cloud native bunch of API gateways coming up, like Traffic, Glue, or Ambassador. And they definitely have the nicer logos. There are some pitfalls that you need to take into account when you work on API gateways. For instance, the thing that I call the accidental enterprise service bus. If you put a lot of business logic, or if you put any business logic at all into your API gateway, you end up with something that is very similar to an enterprise service bus, but doesn't come with the mechanisms or with the tools to manage it, really. So an API gateway is not the right place to implement business logic. And API gateways are often, and this is something that I'm going to talk about in a minute, API gateways are often shared infrastructure managed by a platform team or a systems team or the DevOps team. And that creates an organizational bottleneck. That means you have to run your changes to your API past that group of people, and if they're really mean-spirited, they might not let you go online and cause every kind of problems with that. So, enter Ambassador. Ambassador does have a cool logo and is an open source Kubernetes native API gateway built on top of the Envoy proxy. The Envoy proxy is an open source layer proxy, open source layer 7 proxy, originally built by Lyft. Has an active and responsive community and is easily configurable by machines. That is probably the reason why it's used by Ambassador, Istio, Contour is using it too, and different other pieces of software. I think it turns into a building block of Kubernetes native or Kubernetes native systems that require networking or resilience. So what is so cool about Ambassador? Ambassador stores its data in Kubernetes, so you don't have any additional database which you need to manage. It uses Kubernetes and Envoy for routing and resilience, doing the heavy lifting. Observability is built in. Tracing just requires an environment variable and dumps all that stuff to std. Sorry, and tracing is very easy to implement too. And it enables self-service by teams. And SSL termination is pretty simple. Just drop your certificates in Ambassador certs, Kubernetes secret, and Ambassador picks it up to encrypt your website. However, the really deciding factor for us to go with Ambassador is the self-service by teams. That's really an awesome feature. So how does that work? I have a laser pointer that doesn't really make sense. I'll try to use my mouse. So if you have a bunch of services that are deployed to Kubernetes, you have Kubernetes descriptors, which would be extended with Ambassador or with Kubernetes annotations, so meta information by Ambassador that gets, once your service gets deployed to Kubernetes, Kubernetes informs Ambassador about these annotations. Ambassador builds an intermediate representation of it, which it then turns into a Envoy configuration that it verifies using Envoy to make sure you didn't completely ruin your Envoy configuration. And if that runs through, it uses the Envoy mechanism of the aggregated discovery service to update the Envoy's running configuration. And as soon as that happens, the root is public, and your requests from the internet get routed to the service in question. As soon as you remove the deployment with the service, the route is removed from Ambassador's configuration and is not valid anymore and leads to an error. So let's take a look at so that's actually the way to run Ambassador. If you're on Helm, you just install Ambassador, and that is pretty easy to run. It's very easy to run. Just Helm upgrade it, and if you need a stable IP address because you want to use SSL certificates, you just can, for instance, on the Google Compute Network, deploy that pass that information to Ambassador. We were actually running Ambassador for quite a while with this configuration until we decided it would be a nice idea to have the configuration under version control too. But that worked pretty well for quite some time for us. So this is an actual Ambassador service, or a Kubernetes service that makes use of Ambassador. It's pretty inane because we are just routing a request that will get to the HTTP bin URL to the HTTP bin service and rewrite the host header to httpbin.org because HTTP bin runs on is some kind of virtual service and needs that header. That is literally all that's needed to get a route for live for Ambassador. These mapping annotations can also be used to declare deployment options, like a weighted deployment for canary deployments or shadow deployments, which I know as dark deployments. So basically all your traffic is copied to the new service and the result is discarded, which is something that I think Facebook does a lot. This would be what we would be doing if we decided to host HTTP bin ourselves. We would just deploy an HTTP bin pod on the, in the service HTTP bin and then add a new mapping and give it the weight of 10. That means 10% of every traffic to that URL gets routed to the new service to see how it behaves under load. That is actually quite nice. You can, of course, add requested response headers, and you can use header-based routing like this. So if you wanted to, for instance, route all mobile clients to the mobile UI service, you would be using a user agent, regex to get to those headers, get to those clients and route them to the mobile UI. And you can, of course, route based on host header. There's also an example from the Ambassador documentation. Like here we wrote everything that has the host header quote of the day datawire.io to the quote 2 service, quote of the month 2 service. Everything that matches this regex is routed to the quote 3 service, and everything else gets to the quote of the month 1 service. This is pretty. You can do basic rate limiting with Ambassador for requests. That is pretty nice too. And and that approach achieved the following things. We develop agility. If we can cut our teams around products, that enables them to move fast, take complete control of their of the data flow from entry to return. It removes organizational bottlenecks and gets to organizational scalability, because you don't have to have a central entity that you need to pass through, and it's maintainable because as soon as you remove a route, as soon as you remove a service, the route is gone. There is an Ambassador Pro from Datawire, which is offering commercial support and additional features. I don't know that much about it. Maybe ask Daniel if you want to need to know more. And that's it. Thank you. I have a handful of links.